Alright, welcome to this video where we're going to practice doing some proofs using 3 of the 5 triangle congruence theorems. So we're going to use SAS, which is side angle side, ASA, which is angle side angle, and angle side, which is AAS. So make sure it's big that we understand the difference between these two. So for angle side angle, for this one, your side is directly in between your two angles. So an example of that might look something like this, where if you have two triangles and you have your two congruent angles here, in order to use angle side angle, you would have to have information about the side right in between those two angles. For angle side, your angle does not, or your side does not need to be directly in between your two angles. Maybe you have your two congruent angles here, and then if you have information about any of the other sides besides the one right in between, like this side and this side, then you can use angle side. So making sure you understand the difference is crucial, and make sure you understand too, for side angle side, your information needs to come back to back. So for example, if you have something like this, we can use side angle side. However, if we had something like this, where in this diagram it goes side angle, we would need to know information about this third side in order to use SAS. See how we're kind of skipping one here and then going straight to this one? In this case, we cannot use side angle side. So make sure you understand the criteria. You got to start there before we get into proofs. So again, remember, we're always looking for reflexive property. We're always looking for vertical angles. If we have parallel lines, we're going to use our alternate interior angles. So let's just see, make sure that you're marking up your diagrams with your given, and make sure you guys are also using your proof checklist to help you as well. So given XW is parallel to YZ, so I'm going to label that first. XW is parallel to YZ, and XW is congruent to YZ. It wants us to prove that XYW, triangle XYW, is congruent to triangle ZYW. So again, first thing that I do is I'll make check boxes above each of my givens so that I know that I've used it all when it comes time to, or when we're done with our proof, right? So first things first, we want to write our givens. XW is parallel to X or to YZ, and XW is congruent to YZ, which is given. Now, I can't make any more conclusions from this one. There's no definitions there or anything, so I'm just going to go ahead and check that off because I've labeled it, and that's really all that I can do with it. However, for number 2, or for my other given, I can make some conclusions from that. So I have that XW is parallel to YZ. Now, when our lines are parallel, we want to look to see if we can use any of the angle pairs. Well, I see alternate interior angles here. Now, the first pair I see is the one that I'm labeling right now, so that would be angle XWY is congruent to angle ZYW, and we know that because when lines are parallel, alternate interior angles are congruent, and you want to make sure you're as specific in your reasoning as possible, because you just don't want to leave any room for error. Okay, now there is also another angle pair that we can address from this, right? So we can also say that these two angles are congruent. Again, those are also alternate interior angles. We're just using the other side, the other corners of RZ. So our third statement could be angle XYW is congruent to angle YWZ. And again, it's the same reason again. I'm not going to rewrite it, but you guys have to. But you guys got to say when lines are parallel, alternate interior angles are congruent. Awesome. Now, another thing we're looking for is, are our triangles sharing a side? Well, they are. This side right here, this green side, is being shared. So sometimes it might help, and I'm just going to do this in red here, it might help to separate your triangles. So for example, here we're going to have XYW, and here we'll have WYZ, and you want to carry your labels over. So we had that this angle was congruent to this one, and then we had that this angle was congruent to this one. Now again, when we pull these two triangles apart, this side right here is shared by both of them, right? So in our main diagram, we put an X, and then we also want to make sure we're carrying that X over. And if you don't like to use the X and you like to use tick marks instead, you totally can. Okay. Now, our fourth, we're going to address that reflexive property. You could have also addressed it up here. That would have been up to you. And it can vary, but I'm going to just address it right now. So WY is congruent to WY, and that's because of the reflexive property. And then last but not least, let's see if I have enough information now. Okay, so in this triangle here, I have an angle, a side, and an angle. And in this diagram here, I have an angle, a side, and an angle. So I can go ahead and actually use angle, side, angle to prove that these two triangles are congruent. Remember, with ASA, we needed two angles, and we needed the side right in between those two angles to be congruent, which is what we have. We have these two angles here in both of our triangles, and the side directly in between those two angles in both triangles are congruent. So I can go ahead and use that theorem to say, hey, triangle XYW is congruent to triangle ZYW. And the reason is going to be the theorem that we're using. So we're using angle, side, angle. The angle, side, and angle of one triangle is congruent to the angle, side, and angle of another triangle. All right, let's get started with this one. So again, we're going to look at our givens. I'm putting checkboxes right away to make sure I address both of my givens. I'm going to make my statement and reason chart first, and then I will start labeling. So given AB is parallel to ED, we want to label that with our arrows, and AB is congruent to ED. We want to make sure we're putting our tick marks there. Wonderful. Let's write our given. Okay, first thing that's standing out to me right now, or let me first, okay, AB is congruent to ED. I can't make any other conclusions, and since I have it labeled and written, I'm going to check that off. Now, first thing I see right now, I'm not going to address the other part of the given. The first thing I see right now, I see an X. I see intersecting lines. So when we see our intersecting lines, let's just label the vertical angles right away, because that's a free piece of information that we have. So angle ACB is congruent to angle DCE, and your reason is because vertical angles are always congruent. All right, now let's attack this next part of the given. So we have that AB is parallel to ED. So whenever I see that, I'm looking for my alternate interior angles. I'm looking for my Z's. So I'm going to just do the first one that I see. There's my first Z in green, and you use the inner corners of your Z to identify your alternate interior angles. So I know that angle ABC is congruent to angle CDE, and I actually did something wrong here. We want to make sure we are differentiating with our number of arcs. And our reason here is that when lines are parallel, alternate interior angles are congruent. Okay, now I'm just going to see if I have any, and I'm going to actually go ahead and make sure that I check that off because we addressed it in our proof. Now, since I addressed everything in my proof, I'm going to see, do I have enough information? Well, in this triangle here, I have angle, angle, side. In my other triangle, I have angle, angle, and a side. So I'm going to go ahead and say I can use angle, angle, side now. And what we're using angle, angle, side to say is that triangle ABC is congruent to triangle ECD. And our reason is the theorem that we're using, which was angle, angle, side is congruent to angle, angle, side. Now again, notice, angle, angle, side, right? You need two angles, and the side does not need to be included. It does not need to be directly in between. So we have our two angles here, we have our two angles here, and the side that we have information does not need to lie right in between those two angles for angle, angle, side. Now, for this third step, there was another way that you could have done it, right? I used like the forward-facing Z, but let's do this in like this lighter blue color. You could have also used this Z and labeled these angles as congruent to one another, but that would just mean that your step 3 would vary a little bit. And a lot of times there are different ways of doing it, right? So if you didn't use your vertical angles, right? Let's say we crossed that out and we used this this blue Z here, right? If you look at your triangle, well, then you'd have an angle, a side, and an angle, right? And in this diagram, again, you'd have two angles, and then your side that you have information on is right in between. So in this, you could have also used angle, side, angle as well. But again, it just depends on the route that you decide to go. All right, now there's also examples where we might have some overlapping triangles. So again, we're going to be using the reflexive property here, but I wanted to show you guys a direct example because these can be slightly confusing. So it says prove these triangles are congruent. So it says given angle C is congruent to angle D, and AC, which is this whole side, is congruent to AD, which is this whole side. So the first thing that I do, obviously we're going to write our statement and reason chart, but the first thing that I do when I see a diagram like this, my brain hurts. So I'm going to separate my triangles. So we have triangle AEC, and then we have triangle ABD. Now I did my best to make them look the same, but it doesn't really matter as long as you carry over the correct label. So here we want to make sure we're carrying over our congruent angles. We had angle C was congruent to angle D, and then we also had that AC was congruent to AD. All right, awesome. Now, we've dealt with a lot of examples where triangles were sharing a side, but when they're overlapping like this, what I want you guys to notice, and you can even just look at the letters that are in each triangle, right? Like in this triangle, this is triangle ACE. This is triangle ADB. Even if you just look at the letters, you can see that A is a part of both of those, right? So angle A, when we separate our triangles, the measure of angle A is going to stay the same, right? Angle A, no matter where it is going to be the same thing as itself. So we're going to label that, and that's going to be our reflexive property used right there. And in our bigger diagram, it would just look like this, right? Instead of when we had a shared side, we put an X. When we have a shared angle, we can go ahead and just put our whatever number of arcs you're using, put it on that angle. And then when you separate your triangles, you'll see that they are congruent, right? So let me write in my given, angle C is congruent to angle D, and AC is congruent to AD. Okay. Now, we separated our triangles, right, but that doesn't count as a step in our proof. What does count as a step in our proof is labeling this, the fact that angle A is congruent to angle A. And again, the reason we did this was because angle A is in both triangles. And it really helps to separate your triangles in order to see this. But again, when we say something is congruent to itself, that is the reflexive property. And again, let's go back to our diagram and see what information we have. So here I have two angles, right? In both triangles, I have two angles, and then the side right in between those two angles are congruent. So if you guys got to study those definitions, that is angle side angle. So I can prove that triangle ACE is congruent to triangle ADB by using angle side angle. So the angle of the side and the angle of one triangle is congruent to the angle side and the angle of another. And again, remember that that side, to use angle side angle, that side has to be right in between the two angles that you have information on.